Hello. So this will be the video for group 4, right? Which got the problem statement of designing a more machine that will detect a sequence of 1011, right? A finite state machine. So let's go over the state diagram first, which will make the Verilog code make sense, right? So what this code basically does, right, is that we define five states, right? It's 0, 1, 2, 3, 4, and whenever the 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 code reaches state 4, right, it will output a 1, right, and if it's like state 1, state 2, state 3, it's a 0. Yeah. So here we do so we start here, right, and and depending on the input, it will move, right? So let's say we start here, right? So if the input is 1, then it will start at state 1, and if it's a 0, it moves to state 2. If it's a 1, right, w1, then moves to state 3, and then a w again moves to state 4, and then it will output a 1. So that's the basics of how we will detect a 1011. And here's the Verilog code that will describe this, right? So first of all, we initialize stuff, right? We initialize the libraries, the device, right, with inputs, outputs, the type, behavior, blah blah, and now we get into the logic, which is basically what this is describing, right? So we start at state 0, and depending on the output, right, we move to either state 1 or state 1, or we return to state 0. So we start at state 1, and then if w is 1, we move on to we we still stay at state 1, and if the input is not 1, right, it's 0, then we move on to state 2, and then it kind of repeats until we get to state 4, which is when it kind of changes, where z is now 1. So that means we change the output signal to 1. Yeah. So now I'll be showing the state diagram, right? So no, the signal diagram. Yeah. So this is the test bench that we will be using, right? So we initialize stuff, and then we get a 20 frequency clock, right? 20 nanosecond frequency clock, or like 0 1 0 0 1, and then here's the stimulus, right, which is the w, right? So it goes from like 1 to 0. Yeah. And now we will run the simulation. Yeah. So wait, give me a sec. I will be copying this run code. It's like faster. Yeah. So now this is our uh, waveform, right? So as you can see, it does what we want it to do, right? So let's start here, right? It's a 1, right? So when the clock edge rises, it it will change the state depending on the input, right? So it's a 1, and then since it's a 1, we ignore this one, right? So it's a 1, and then here it becomes 0, here it becomes 1, and here it becomes 1, right? And because the previous states are like 1 0 1 1, the output jumps to 1. And now here, since the input is 1 again, right, it will move down to 0 again. Yeah. So and then here basically it continues doing, right, and we see that it doesn't trigger because we've not put in the correct sequence, right? This is like 1 0, so this is like 1, and then it becomes 1 0 1 0. Yeah, so it's working as intended. Yeah, so that's it. Thank you.